Okay, we're going to kick off this physics course with a fairly easy introduction, which is to do with the realm of physics. Then we will look at measurements and uncertainties, and then vectors and scalars. First of all, the realm of physics. What is the realm of physics? This is looking at sizes, masses, temperatures, and so on, which go from small to big. And when I say small, I mean very, very small. And when I say big, I mean very, very big. The complete range. Chemistry deals mostly with a fairly small scale. Biology, intermediate scale. Physics does the lot, from the very smallest scale to the very largest. We need to use an estimation which is basically to the nearest order of magnitude, which is basically you say something is 10 to the n meters or meters cubed or whatever. For example, you have 1 meter, which is 10 to the 0. We have 10 meters, which is 10 to the 1. 100 meters is 10 to the 2. And 1,000 meters is 10 to the 3. So we need to be able to describe things to the nearest order of magnitude. My height is around 180. So to the nearest order of magnitude, I would say roughly 1 meter, which is 10 to the 0 meters. You need to do calculations and estimations such as how many heartbeats are you roughly going to have in a lifetime. Think how many heartbeats you have in a minute, in an hour, in a day, how many days in a year, and estimate 70 years. Multiply these together without using a calculator, and you'll get an estimate, and that basically is the number of heartbeats in your lifetime. Your height is going to be pretty much the same height as me, to 1 order of magnitude. The radius of the nucleus, these are facts that you should know. The radius of a nucleus is around 10 to the minus 10 meters. The mass of an electron is roughly 10 to the minus 30 kilograms. The distance to the nearest star is around 4 light years away. How far does light travel in a year? Well, light travels at 3 times 10 to the 8 meters a second. How many seconds are there in a minute? In an hour? In a day? In a year? And multiply that by 4. Then we have the distance to the nearest star. Not the sun, of course. We have to state the ranges of magnitude of distances, masses, and times that occur in the universe from smallest to greatest. So we've really just looked at that. The smallest distance is 10 to the minus 15 meters, is roughly the size of a proton, the size of a small nucleus. 10 to the 25 is the size of the visible universe in meters. Masses, the smallest mass is around 10 to the minus 30 kilograms, the mass of an electron, to 10 to the plus 50 kilograms, which is the mass of the universe. Times, the smallest time that you can estimate is the time it takes light to travel across a nucleus, 10 to the minus 23 seconds, to basically the age of the universe, 10 to the 18 seconds. If you want to know how many electrons are needed to make up the nucleus, you need to find out how many this go into this. Now we need to take these orders of magnitude and basically compare them, do ratios. A little estimation is to find the volume of this room, the room that you're in, to the nearest order of magnitude, and find out how many tennis balls will fit into the room. How do we do this? First of all, find the volume of the tennis ball. Secondly, find the volume of the room, and then find out how many tennis balls will go into the room. How many protons fit into an atom? Find the volume of a proton, find the volume of an atom, and see how many protons will fit in the atom. The diameter of a proton is roughly 10 to the minus 15 meters. The diameter of an atom is roughly 10 to the minus 10 meters. That finishes the brief introduction.